Imagine a world where things can exist in multiple places at once. A world where objects can be entangled and instantly affect each other, no matter the distance. Welcome to the fascinating world of quantum mechanics. This isn't a realm of science fiction or fantasy, but a part of our reality, a cornerstone of modern physics. Quantum mechanics, with its intricate web of paradoxes and enigmas, has been puzzling and inspiring scientists for over a century. It's the science of the incredibly small, governing the behavior of particles at the atomic and subatomic level. Within this video, we'll embark on a journey, exploring the birth of quantum theory, its key concepts, and real-world applications. We'll attempt to untangle the complexities of the quantum world, a world that challenges our everyday understanding of reality. So buckle up for this thrilling ride. Stay tuned as we delve deeper into this enigma, unraveling the mysteries of the quantum world. In the early 20th century, scientists began to notice that classical physics couldn't explain certain phenomena. The universe's smallest particles, like electrons and photons, didn't seem to play by the same rules as their larger counterparts. This was a conundrum that stirred the pot of scientific thought and led to the birth of an entirely new branch of physics, quantum theory. Classical physics, the tried and true theories of Newton, seemed to crumble when faced with the peculiar behavior of these tiny particles. For instance, the concept of light behaving as both a particle and a wave was far from Newton's laws of motion. Things didn't add up, and it was clear that a new perspective was needed to understand the building blocks of our universe. Enter the quantum theory, a realm where particles can exist in multiple places at once, where they can spin in two directions simultaneously, and where observing a particle can actually change its state. It was a theory that turned our understanding of the universe on its head. The journey to this revolutionary theory wasn't a solitary one. It was the collective effort of some of the brightest minds of the time. Albert Einstein, Max Planck, and Niels Bohr, among others, contributed significantly to the development of quantum theory. Planck was the first to introduce the idea of quantized energy levels, suggesting that energy is absorbed or emitted in discrete packets called quanta. Einstein furthered this idea by explaining the photoelectric effect, which showed light acting as particles. Niels Bohr then proposed his model of the atom, incorporating quantum theory to explain why electrons don't simply crash into the nucleus. These groundbreaking ideas were met with skepticism, but as more experiments confirmed their predictions, quantum theory gained acceptance. It was a radical shift in thinking, challenging our understanding of the universe and forcing us to accept that at its core, everything is a bit, well, strange. This was the beginning of a revolutionary era in physics, opening doors to a whole new world of possibilities. Quantum mechanics operates on a set of principles that may seem bizarre to our everyday understanding of reality. Let's dive into these key principles, starting with wave-particle duality. Imagine you're wearing a hat. To some people, it might look like a baseball cap. To others, it's a beanie. The hat hasn't changed, but the way it's perceived has. This is similar to wave-particle duality. In quantum mechanics, particles like electrons and photons can exhibit characteristics of both waves and particles, depending on how we observe them. Next up, we have superposition. Think about flipping a coin. While it's in the air, before it lands, it's in a state where it could be either heads or tails. This is comparable to superposition, where quantum particles can exist in multiple states at once, like the coin in midair. It's only when we observe or measure them, much like the coin landing, that they snap into one state. Finally, let's talk about quantum entanglement. Imagine you have a pair of gloves, one left-handed and one right-handed. If you pack them in separate boxes and send them to opposite ends of the world, without opening the boxes, you wouldn't know which glove is in which box. However, the moment you open one box and find a left-handed glove, you immediately know that the other box must contain the right-handed glove. Quantum entanglement is a bit like this, but way more mind-bending. In the quantum world, two particles can become entangled so that the state of one immediately affects the state of the other, no matter how far apart they are. These principles, as strange as they may seem, are what make the quantum world so intriguing. The way quantum mechanics defies our intuition and everyday experience is what makes it so fascinating. And remember, as Albert Einstein once said, the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. You might be wondering, how does quantum mechanics affect me? Well, let's dive right into it. Quantum mechanics may seem like a lofty concept, distant from our day-to-day lives, but in fact, it's closer to home than you might think. For instance, take the marvel of quantum computing. Traditional computers use bits, which can be either a 0 or a 1. Quantum computers, on the other hand, utilize quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a quantum quirk called superposition. This means quantum computers could potentially perform complex calculations at a speed that leaves even the most advanced traditional computers in the dust. Next up, let's talk about quantum teleportation. Now, this isn't about beaming people from one place to another like in science fiction. Quantum teleportation is about transferring the state of a quantum particle from one location to another without any physical link. In simple terms, it's like transferring the identity of one particle to another. While we're not teleporting humans yet, this breakthrough could revolutionize the world of secure communications. Quantum mechanics also shapes the technology we use every day. Have you ever wondered what makes your smartphone screen so bright and colorful? The answer lies in quantum mechanics. Tiny particles called quantum dots emit light in response to electric current, and they can be tuned to emit specific colors, making your screen vibrant and sharp. And let's not forget the Global Positioning System, or GPS. The ultra-precise time measurements required for GPS to work are only possible due to the principles of quantum mechanics. Without understanding quantum mechanics, we wouldn't be able to navigate our way around the world as easily as we do today. So, while the realm of quantum physics might seem distant and abstract, its principles are at work all around us, influencing the technology we depend on and the future of computation and communication. Quantum mechanics, despite its complexities, has a profound impact on our daily lives. As we conclude our journey through the quantum realm, we realize how this seemingly strange world shapes our reality. We've delved into the birth of quantum theory, explored its key concepts, and witnessed quantum mechanics in action. These intricate principles work behind the scenes, influencing everything from the tiniest particles to the vast expanses of the universe. Quantum mechanics is not just theoretical, it's incredibly practical and poised to revolutionize future technologies. It's the backbone of quantum computing, nanotechnology, and even teleportation. Ideas once confined to the realm of science fiction are now becoming science fact. This is the power of the quantum world, a world that challenges our understanding and defies our expectations. But the journey doesn't end here. Keep the curiosity alive. If you enjoyed this journey through the quantum world, please like, comment, and share this video. Don't forget to subscribe for more engaging and enlightening content. Remember, the quantum world is just a click away.